Hello guys, welcome back to my channel. Today we are going to be discussing the sliding window pattern. The sliding window pattern is also another popular pattern that is used in algorithmic problems. And the idea is basically simple. So we have a window and that window slides. And to put it into a better context, actually, so the window sort of expands and shrinks based off of some condition. So these two things happen to the window based off of some condition. So usually those questions are questions such that you are given an array and then the array has a particular size, and then you now need to determine a window right within that array that satisfies some condition, or that gives you, or that maximizes a condition or minimizes a condition. So we'll take an example now. Say that you are given an array of let's say you have the numbers, you're given an array, you have the numbers 2, you have 3, you have 2 3, say we have like -4, we have 5, we have 1, then say we have -12, then say we have -3, then say we now have the value 6. And then you have a question that tells you that you should return the indices that represent the bounds, right? So we want like the bounds of a subarray within this array whose values sum to a max. So basically we want a subarray within this array that when we sum the values together gives us the maximum value. So how do we find that? How do we solve this problem? How do we find the subarray? Now in this case, what we need to do is we sort of need to do something similar to what we have spoken before, the sliding window, the two-pointer pattern. However, we just need to, in this case, we need to sort of rethink the process just a little bit. So in this case now, imagine that I have a window here. So let me just duplicate this so that we could have this for, okay, no, not that. So let's duplicate this whole thing. Okay. All right, this is good. I'm missing one more thing. Okay. So now that we have this, we need to find a window within this entire array that contains the maximum. So that will mean something like, in this case now, this is a window of, so let's just pick the pen, let's use the green marker. This is a window of size 6. Of size 5. That's 2 plus 3. This is a window of size 6. This is a window of size 6. Just this one. This is a window of -12. This is a window of -3, right? So you can imagine that we have different combinations. Let's say from this window to this window, we have a window of size 1. So the question is, how do you find a maximum window within this entire window? How do you do it? That is one of the problems that sliding window helps you to solve. So ideally, if you're to solve this problem with a brute force approach, you probably have something similar to two loops, right? So you have one loop that would initially loop through all the elements. So we have a loop that will go from I is equal to 0 all the way to the entire length of the array. Then you have another loop that then goes from j is equal to I plus 1 all the way to the length of the array. Once you are done with that, then you will sort of create a sum a sum variable just before this J array, and then you would sum up all of the values from J. So initially you sum I to this sum, then you begin to do a sum plus equal to J. Plus equal to the array at the element at index J. So you do that, and then you keep comparing. So you probably also have a max variable outside where you can easily compare and be like, okay, the max will be equal to the max of the current max and the sum. Current max and the sum. So the max of either one of these two. This is what you normally do. And if we analyze this is actually this is time consuming. So initially you go through the entire array the first time, and then the entire array second time within the same loop. This is n squared, and this is bad. We can actually do better than this. This is where sliding window shines. So for these kind of problems, what we can do is you can assume that we have 2 pointers, right? So these pointers will represent the beginning and end index of this array. So let's just have another copy of this input so that we can easily analyze this problem. So now, using 2 pointers, what do we do? In this case, we just need to now create 2 pointers. So one will be will represent the leftmost edge of the array. The second one will represent the rightmost edge of the array. Yeah. So initially we have a window of size 1. Both pointers are pointing to the first value. So what next do we do? We sort of then move the right boundary to the next. So once we move the right boundary to the next, what now happens is that we can now immediately see, so initially we have a sum of 2 in the first position. We had a sum of 2. Then the next thing is when we move the right boundary, the red one, to the next, then we have a sum of 2 plus 3. Then we have 5. So you remember that we will have a maximum value that we'll be keeping track of. So initially we can initialize this as 0, or some value that is significantly less than 0. Something less, a very negative value. So now at this point we have 5. This value 5 is more than the max, so actually initially we will have incremented the max from 0 to 2 when the 2 pointers were initially pointing at the same thing. Then when we move the pointer to the next, then we increment it to, if you compare 2 plus 3, that's 5, and then 5 is higher than this, so this will become 5. So actually what is happening is that if you imagine that this is the left boundary of this window where this black pointer is, and then this is the rightmost boundary of this window. So this is the initial window we have at this point. What happens next is remarkable, right? So what happens is we then sum the next number. We attempt to expand this window further to include this 4 this way. So now the window now becomes of size plus minus 4. Yeah, so we now have 5 minus 4. And then what do we have? We now have 1. This window is reduced in size, because of this negative number that we had here. However, the number is still a positive number. It is not less than 0. Yes, so that means that we should probably still keep this entire window because we might find something greater. All right, so we do that. We keep the window, but we realize that this new sum of 1 that represents this entire window is not a maximum value because we already had a maximum value of 2 and 3, 5. So we cannot update this. Okay, so we continue the process. We move this window forward again. So now moving the window forward, now we have a plus 5. This now gives us a value of 6. Now this new sum of 6 is larger than the initial max, which means that we can update our max now to 6. This now means that we have a window that actually starts at a at this index position of 2, of 0 I mean, all the way to index position 3, containing all of these values, and gives a maximum of 6. So far so good. That's what we have. Well, then we continue. We expand the window again. Now expanding the window again, we now have a value of +1. And then this becomes 7. So now we have a window of size 7. We can update our marks to 7. Now the next thing is we attempt to expand the window again, like we were doing before. Now we have a negative value of -12. So we have 7 minus 12. This now gives us a -5. Now at this point, we realize that we have an entire window that gives us a negative value. And what we are looking for is a subarray within this entire array that gives us the maximum positive value. The question you will now ask yourself is, does it make sense to include this entire subarray that gives us a negative value and attempt to expand this further to include -3? Or does it make sense to immediately discard the way of everything before? Now, how do we answer this question? It's pretty simple. What we just do is we compare what is the value of the sum of everything we had here initially, which we got as -5, plus including this -3. Yeah, so we are going to compare -5 minus 3. It gives us -8. To just shrinking the entire window to only include this new -3. Which of these makes any sense? Or rather, which of these is greater, -3 or -8? You can see that the question is now easy to answer. We know that on the number line, -3 is greater than -8. So if you do the whole number line, so you have all of this, blah blah, all the way to -8. So this is definitely greater. So that means that if we are looking for a maximum value, yes, we should discard any subarray that gives us a negative value. So that means that immediately we saw that there was a -5 from a subarray of this size, we should immediately discard this subarray and shrink the pointer. So this is where the pointer idea came up. So we just shrink the entire pointer, and then this comes here. So initially this will all be here, and then we shrink this, and then this comes here. Then we continue to do the same thing again. We expand the pointer includes 3. We check the value of this. We now realize that this gives us a value of -3. This -3 is definitely lesser than the overall sum, yeah, or the overall maximum, so we can no longer use this. Question now is, should we include this -3 in the next subarray that we want to create? Should we expand this subarray this way, or should we discard this -3 and then shrink it to only include this? So from what we answered before, it's pretty obvious that if we are to include the -3 with the 6, we'll be having a lesser value compared to if we had if we shrink that subarray and only included number 6. Right, so to put this into perspective, imagine that this was a multilateral number. Imagine that the number here was let's imagine the number here was a 9. So in that case, what would have happened is would have ended up at this being a -3, and then if we were to include this 9 alongside this array of size -3, what will happen is we would end up with a subarray of size -3 plus 9, which will give us what? Which will give us 6. Question now is, this 6, is it larger than the 7? No, it's not. But meanwhile, if we have realized that we already have a negative value, we should not be trying to evaluate a negative value. Once we have a negative value, a value that is less than 0, this means that expanding the subarray will eventually give us a value that is lesser, and it will make more sense to actually shrink that array into the next one. So basically we are trying to exclude any negative subarray sum. So now with the subarray first pointing to this, we can realize that we immediately eliminate the minus 3 parts, and then this gives us just a 9. And now we can compare this value of 9 with initial sum and realize that actually 9 would have been a better value. We would have missed this 9 if we did not realize that we could shrink the subarray. So this is a very practical example of a situation where the sliding window pattern becomes really important. As a recap, the idea is we can expand and shrink a subarray based off of a condition to eventually return back an optimized value, which could be a maximum, a minimum, or some form of sum. Alright guys, I hope you've been able to learn a lot today, and I hope that you keep on practicing to improve your craft. I'll share some questions that you can review so that we can get our hands more dirty. Thank you very much for joining me for today's session. See you guys once again, and don't forget to like, share, and subscribe.